Alright folks, welcome back. In this video we're going to discuss another example of normal distributions and calculating probabilities of values in a normal distribution. So remember, normal distribution is that bell curve that we see, and in order to find the probability of a value in a normal distribution, there's a couple ways we can do that, and we're going to talk about them both today. So we're going to talk about calculating the normal distribution by finding the z-score and then using the standard normal distribution table, which we see on our right, and then we're going to talk about doing it with the calculator that's given to us this week. So let's take a look at the problem that we're going to be working with today. So here, the problem reads, the average amount of money that families spend on groceries per month in a city is $120.55. And a standard deviation has been found to be $30.95. We want to find the probability that a randomly selected family has spent more than $155 that month. Then we want to know, would that grocery bill be considered unusual? Okay, would a grocery bill that high be considered unusual? So there's two parts of this problem. First of all, calculate the probability. Second of all, is that probability unusual? So let's talk about it. We want to look at the probability that the bill, in this case X, is greater than $155. Greater than $155. So how do we do that? Remember, in order to find probabilities, we need to calculate the z-score. Okay? The z-score, remember, is given to us by X minus the mean divided by the standard deviation. X minus the mean divided by the standard deviation. X is the value they're asking us about. The mean and the standard deviation are given to us in the problem. So X is 155. The mean is 120.55. And again, we got those straight from the problem. So the X value we're looking for is 155. The mean, they tell us right in the first sentence there, is $120.55. And the standard deviation was $30.95. So 30.95. So calculating this with some rounding, we get a z-score value, which is equal to 1.11. So that's our z-score. Now remember, recap of what the z-score actually tells us. So in our normal distribution, which is our bell curve, what we do is we standardize it, which means we center it at a mean of 0. And then the z-score becomes all the values along that x-axis. Specifically, the z-score, remember, tells us how many standard deviations away from the mean our specific value is. Now, our z-score was 1.11, which is greater than 0, right? So our z-score falls over here, let's say, at 1.11. Now, our problem was asking, what is the probability that X is greater than 155, right? A bill larger than $155 is what we're looking for. So since we're talking about a greater than problem, we're looking at everything to the right of our z-score, because remember, that arrowhead points to the right. So we're looking at a greater than, which means it's everything to the right of our z-score 1.11. Okay, so what we're looking for is the percentage of the bell curve to the right of 1.11. This right here is our p-value, which tells us probability. And we can find that p-value by looking at the standard normal table. But there's one extra step we have to do here as well. So first of all, let's identify and find our p-value and by looking at our z-score table. So looking at the table here on the right, we want to find 1.11. So the leftmost column here gives us all of the first two digits, and we want to look for 1.1. And lastly, we want to go over 2, which gives us in that column of 0.01, which is the last digit of our z-score, and we find a probability of 0.8665. Our p-value is 0.8665, but be careful. The probability that the standard normal table gives us, take a look at the picture at the top, is everything to the left of our z-score. Everything to the left of our z-score. But that's not what we want. We want everything to the right of our z-score. So how do we find the opposite? That's what we're given here, right? We're given the opposite of what we want. We want everything to the right, but we're given everything to the left. How do we find the opposite in probability? We take 1 and we subtract the probability that we have from 1, and that gives us the opposite. So the probability we found here of 0.8665 is the probability that x is less than 1.11. That's the probability we found, but we want the opposite. So we want the probability that x is greater than 1.11, which is equal to 1 minus the probability that x is less than 1.11, which is what our standard normal table gave us. So this is equal to 1 minus 0.8665, which is equal to 0.1, let's just say 13. We're just going to round here, that's okay. 0.13, or about 13%. Now, there's some, it's not exactly that, it's like 0.1335 or something like that, but we're just going to round it to 0.13 to make our lives easier, because that's about 13%. So what does that tell us? That tells us that the probability that this particular family spends more than $155 is 13%. 13% is the probability that a family selected at random will have spent more than $155 on groceries. Now, we can confirm that or check it another way by looking at the other calculator that's built into our Excel spreadsheet. So we can plug in all our values. The mean that was given to us in the problem was 120.55 with a standard deviation of $30.95. Now we have to decide which calculator we're going to use. The one on the left gives us everything to the left of our z-score. The one in the middle gives us everything to the right, which is the one that we want to use here, which is the x value we're looking for is 155. We hit enter, and sure enough, what do we get? 0.1328. And once again, the error there, the difference in the values that we got are rounding, okay? But in general, look at the root there, 0.13 or 13%. So we know that there's a 13% probability, no matter which calculator we use, whether we do it by hand or whether we use the calculator, there's a 13% probability that this family will have spent more than $155. Now, that's the first part of the problem, okay? The probability that x is greater than 155 is equal to 13%. That's part one of the problem. What's the probability? 13%. Now the question is this unusual? Now, if you saw the previous video, once again, what is the cutoff for an unusual event? We say in probability, if any probability is less than 5%, we would consider it unusual. If any probability is less than 5%, that event is unusual. Is our probability less than 5%? Is 13% less than 5%? Absolutely not. So this would be considered usual, or simply not unusual. This event is not unusual. Okay? So to recap, we found the probability of this event, then we determined whether it's unusual. We found the probability by finding the z-score, by looking in our z-score standard normal distribution table, looking at the p-value, and we've realized the p-value actually is for less than our standard deviation, or than our z-score, but we want greater than because we're working with a greater than problem. So we had to do 1 minus the probability that the z-score table gave us, and then we were able to find our p-value. We also confirmed this using the calculator, and then we decided is 13%, which was our probability, is that less than 5%? Well, obviously not. So since it's not less than 5%, we would not consider this event unusual. All right, guys, check back in for more examples. I'll see you next time.